All right, for corrections, I'll want you to write on your quiz, unless that makes you feel uncomfortable, in which case go ahead and write it on another sheet of paper. But at the end of the class period, you will turn in the notes and corrections that you have made here with me today, and I will use that to change your quiz grade. Okay?
To a 70?
To something much better than you have, yes. Because I do have a few people who hit 70 and higher. So they're going to get curves as well. But if you didn't quite get to the 70, this is definitely going to get you at the very least to the passing. Okay? So please take really great notes on these. Make sure that you're understanding. And if you're stuck on things, that you're being really vocal today and asking. Because tomorrow, I'm putting everything back up on the whiteboard, changing numbers and diagrams again, and asking you to do it all over again. And I'm going to take that as a test grade, and that's the one we're keeping. All right? All right, here we go. Number 1 asked you to identify the point of concurrency. Right? That's what you're asked to do. And I have a paper here that had a figure that looked something like this mess.
That's what I have.
You had this one, and it was like, there's so much going on. Okay, I didn't draw it beautifully here. But there's so much going on. Where do I even start? You start with your notes. Point of concurrency. That's a special point in a triangle, so I'm going to go to that section. He's saying it's a centroid. The big question you have to ask yourself is, what kind of special segments am I looking at? Yeah, I have a triangle, but if I look at, say, this one right here, which segment is that? Median, he says. Median because it goes from vertex to some point, and that point cuts this into 2 congruent pieces. It's the midpoint. So I'm going to show from my notes, there is the median, the segment connecting vertex to midpoint. There's your picture. But you have 3 of these, so it makes this thing look like a hot mess. But if I look, my picture 1 looks a lot like the thing that was on the board. Much neater done, because I was being careful with this one. And 2, look at the definition. The point of concurrency of the medians of the triangle. Now take a look at these other points. So you have centroid, that's 1 point of concurrency. Here's the orthocenter, the point of concurrency for the altitudes. Notice I have altitude. It goes from vertex to some point at a right angle. Doesn't care about congruent anything, obviously. No one cares about congruent anything on altitudes. You just have to go through a vertex and hit at 90 degrees. Make sense? Look at circumcenter really quickly. Point of concurrency of the perpendicular bisectors. Perpendicular bisectors are both 90 degrees and congruence. And so that's how you identify what point of congruency you're looking at, is you go, well, what segments are being used to create this thing? Okay? So fix your number 1 now based off of your notes. Yeah, and I got a lot of this. You located it. Good job. Like this. You located.
I located.
Yeah, I don't need a location. I want it, and then I got some of this too. Yep, you located it. That is indeed the point of concurrency, but which one? Is it a centroid? Is it an orthocenter? Is it an incenter? Is it a circumcenter? Which one? Depends on the definition. Okay? So y'all are already saying, and I'm ignoring it, but you guys are using the right subject. Yeah, write that down. Yeah. You should have your notes out so that you can refer back to your notes. All right, let's look at number 2. Number 2 was a solve for X thing, and you were asked to show your work, and I gave you this mess. This is more than anything an algebra work, algebra operations. And it asks you to identify what you're looking at. I'm looking at some fraction equal some other fraction. Whenever I have some fraction equal some other fraction, this is called a proportion. And all proportions can be solved using cross multiplication. And so the first thing I was looking for was evidence of you going, I want to use cross multiplication. For a lot of you that looks like this. Multiply those two together. But make sure you put them in parentheses when you do so. Because I saw a lot of this. You're identifying I'm using cross multiplication. You identify that you need to multiply them together, but without those parentheses, this looks like x plus 1 times 2. You have to do those multiplications first. 1 times 2 is 2, and so it looks like this should be x plus 2. Whereas this thing says, I'm multiplying the 2 by everything inside the parentheses. This becomes a distribution moment. 2 times x plus 1 times 2. And notice there's a big difference between those two expressions. So take a moment, solve this down, get an x equals something number. Let me see your algebra work step by step. Okay, can I go on to the next one? Okay, you're going to finish that algebra on your own. All right, here we go. Number 3 was identify the segment. Going back to your notes, going back to those segments. What do you see? We see a 90 and 2 congruence. Which segment had the 90 and 2 congruence?
Median.
Read the definition of median.
Perpendicular
Perpendicular
bisector.
bisector was the one that was both 90 degrees, because 90 degrees means perpendicular, and congruence on either side, because that's created by a bisector. So this one was a perpendicular bisector. Not a median. Median doesn't care at the angle. Notice how you don't have that 90-degree marking? Yes, sir. Mm-hmm. All right, let's look at number 4 very quickly. Number 4 says classify the triangle, and you were given side lengths of 28, 70, and 45. I saw a few answers like this. This is scaling. You're not wrong, and so I had to give you credit for it. But because I didn't tell you that I wanted you to classify it as a right, acute, or obtuse triangle. So I will make sure that tomorrow I'm more clear. These are the 3 answer choices I'm having you look for. So how do you do this? Yeah, we're going to look at a squared plus b squared. See how this value relates to whatever we get when we square c. There's three options: less than, greater than, or equal to. And they refer to one of these three choices over here. If they're equal, it's right. If the a squared plus b squared side is greater than the c squared side, it's acute. And if it's the other way around, less than, it's obtuse. The next concern that I saw was not finding the longest side. For this to work, the longest side must be C. And so which of these three numbers represents side C? The 70. If you accidentally put any other letter in there, any other number in place of C, you generated the incorrect relationship. Okay? So take a moment on your paper, make sure that you substitute those into the right spot, calculate it down, some number in relationship to some other number, decide whether it's less than, greater than, or equal to, excuse me, and then do your calculation, your classification.
Just put A, B, C, and numbers.
You just put A, B, C in order?
And then they write.
Let me see. Did I read too quickly?
Oh no, break it and do
Yeah.
the line.
Yeah. Okay. Then fix it. So that way you know for sure how it's supposed to go. And that was probably I graded too quickly on yours. And congratulations for the extra points.
You just put wrong word, no word for me.
Yeah, no worries.
You get plus 5 and a check.
I put +5 in a check mark, likely because you missed something along the way and I gave you some credit for it. I like partial credit. Yes, ma'am. I have someone out. Can you wait? Thanks. Okay, giving you guys a few minutes to classify this.
A squared plus b squared is greater than c squared.
Okay, he's saying that it's going to end up being an acute triangle. That a squared plus b squared is going to be bigger than c squared. All right. If you say so. I don't know. I didn't run the numbers. All right, let's look at number 4. Number 4 wanted to know what is the value of x in this triangle. What triangle? What kind of triangle are you looking at?
Right.
So can you use a squared plus b squared equals c squared?
Yeah.
Awesome. Do it. But the problem is which one is c?
The one opposite of the right.
The one opposite this right angle. So if you got it incorrect, likely you might have put this number in the wrong place. There's another way to do this one. And this was to recognize it as a Pythagorean triple. On your chart for Pythagorean triples, let me pull out mine. I have it filled out, and look, there's my 9, and there's my hypotenuse of 15. So what's my missing side? 12. And so this side is 12. And I would have completely allowed that without work because this one hit, did I say show your work on this one? No? Okay. I would have been just okay with just the number. If I had said shown your work and you used a Pythagorean triple, you can write used Pythagorean triple. And I would have been like, all right. Because then your work is I recognized a pattern and I had it do the hard stuff for me. And I'm okay with this because I really do want you recognizing these patterns. Okay? So either one of those two methods would have worked. So Pythagorean theorem, a squared plus b squared equals c squared, or one of your triples. Decide which method you're going to use. Move down to get the correct answer. I'll give you a few moments. All right, thumbs up. You ready for the next one? Thank you, 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 thank you. All right. We want to use a special right triangle, and we want to use it to help us find the values of x and y. And we're asked to state which special right triangle we ended up using. Okay? Well, we have, if you go to your notes on the section with special right triangles, there are two of them. We have a 45, 45, 90 and a 30, 60, 90. These names are telling you what the angle measures of your triangle are. I gave you an angle. Do you see it? Here's your 30. So that means since this triangle right here doesn't have a 30 in its name, it's not that one. It has to be the other one. Looking in your notes under 30, 60, 90, you should have a setup that looks something like this. I'm going to tell you right now that using the Pythagorean theorem on this guy is challenging. Not impossible. You could totally do it and generate the correct answer, but it's challenging. And so I want you to, again, use patterns to make it so there's less physical work you have to do. Looking at this pattern, what this pattern says is that the side across from the 30 is your landmark number. I don't know what it is, but whatever it is, all the rest of these sides in the triangle are going to depend on that number. In particular, the hypotenuse is always going to be 2 times whatever this one was. All right, so that's helpful. Here is the hypotenuse. So this is going to be 2 times whatever this side across from the 30. Oh, man. That didn't help me with numbers. So let's look at the third side to see if that gives me some clues. Across from the 60 is this guy right here. I don't have this angle marked, but notice I have 30, I have 90. This must be 60 to complete my 180 degrees. And so across from the 60 is that beast right there. Look at the difference between the two of them. See how similar they look? In fact, if I cover up the square root of 3 on each one, what value does x have? 2. This x right here is the same as this x here, which means if this number is the same value as this side, then this side's measure is no calculation required. Just looking at the pattern. What did we say this side measure was equal to? 2 times whatever this one was. This one was 2, so 2 times 2 is
4.
And now you have the measure for this side. Does that make sense how you use this guy? I want you to have it try to make a little bit of sense, because I remember being introduced to it about this same time that you're being introduced to it in high school, and it making no sense to me. I don't know how I passed that class without this. I was like, I don't know. I'm just doing stuff, and I don't get it. And it wasn't until 10 years later when I was in a college class and having to do it all over again that I went, oh, that's what that meant. I felt really smart. No, not really. I felt really dumb. But do you see how these two are related? And then that can give you clues as to what that value of the shortest side is? Yes? No? Yes? Michelle? Yeah? All right. All right, let's go on to number 7. This is the proofs one. Proofs are challenging. I'm just going to state it out. They're hard. And there's nothing easy about them, and I get it. But I'm not here to give you a bunch of easy stuff, because if I give you a bunch of easy stuff, you didn't learn anything new. And then what's the point? I want to give you stuff that is challenging for you, that makes you think and makes you work, because that's when you grow and become a better person. So you had this setup that looked a lot like this. Oops, I realize I'm writing off screen. Let me zoom out a little bit so you can see everything. Right? And you were given this statement here. In a proof, you have some statements, some things that you were saying are true, and then the reasons that tell everyone why you said that was true. And this is the format by which everything, really, is used when you're defending an argument or a position that you have. Are you in English class? Are you having to write maybe a persuasive or an argumentative essay where you have to convince someone of your point of view? This can help you out. The given is the argument you start with. The prove is the point you're trying to make. And all of these other statements are things you're saying, this is a fact because of this reason. Okay? I'm going to fill out the rest of the chart here real quick for you so that you can see where these are coming from. All right, and I'm abbreviating the very last reason because I don't want to write out the corresponding parts of congruence. That's too much words. I don't want to write it. In a 2-column proof, you are always starting with what's been given to you. First reason is always given. Always, always. I don't care where you are, the first reason in a 2-column proof is given to you. Because it's given, literally. The very last statement in your proof must always be the statement that you are trying to show is true. Always. The last statement of your 2-column proof is always the statement that you're proving. It's the proof. So now we got to figure out what goes in the other spots. In this second row, the second row here, the statement is blank, so you have to write a statement. And you have to write it because of what the definition of bisector tells you. So what is definition of bisector? And I saw several of you write in the definition right here. And that was really cool. Yeah, intersects to create 2 congruent parts. And since these statements are all talking about congruence, turn it off. You're with us right now. Thank you. Because these statements are all talking congruence, notice how we have congruent to, congruent to, congruent to, congruent to. This statement is also going to have something to do with congruence. Look at the given. What's being bisected? What's being cut into 2 congruent pieces?
Triangle ABC.
Triangle ABC or angle ABC?
Angle ABC.
Angle ABC. So in our picture, angle from A toward B toward C. That angle right there is being cut by segment DB, this segment right here, to create 2 congruent pieces. Those 2 angles right there. Which means our statement, because the definition says so, is that these 2 angles in here are congruent to each other. Does that make sense? The big question is how do we name these angles? Right? So far, we've got this angle A, but I can't name this one B because do I mean this B that got cut or do I mean each of these little 2 pieces of B? I mean the 2 little pieces of B, so I've got to find a different way to write it. Notice the pink angle. I went from A toward B toward C. So if I wanted to name this angle piece right in here, what could be a valid name?
ABD.
A toward B toward D. Don't forget the angle symbol. angle ABD. Which angle is that one congruent to?
DBC.
DBC. Yes. Write it in. Don't forget your angle marker. So now you have this set up, and the next statement says these two triangles, this triangle right here, ABD, is congruent to this triangle here, CBD. And they want to know why. What's the reason that you're saying these are congruent? Well, in your notes, we had a whole section on congruent triangle theorems, yes? So that's the section that you're going to go flip through and you're going to look at. So go ahead and flip to that section, triangle congruence, and you're going to find that you have side, 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 angle, side, angle, side, angle, and angle, angle, side. Sure, there's the ones with the right triangles, but I don't know if these are right triangles. Nowhere in my proof does it say I have a right triangle, even though it looks like I do. So I can't use any of those, so I'm going to ignore them. These are the only four that I'm going to work with. In order to use these triangle theorems, you have to have these items congruent to each other. All three sides. Two sides in an angle. Specifically, the angle that's trapped between those two sides. This one, two angles and a side. Specifically, the side trapped between the two angles. And this one, two angles and a side, but this is the side that's free. He's not trapped. So what information do you have? From the given, I have a segment, I have a side, and I have an angle, right? And from this line, I have another angle. So I have two sides and an angle, yes? Does that mean I have information for side, side, side? No, because this one requires three sides, and I don't have three sides, I only have one. What about side, angle, side? No, because this one requires two sides and one angle. And I have two angles and one side. So really, my choices are this one or this one. 50-50 if you're not sure which one to pick. But here's how you know which one to pick. Do you see this order? Angle, side, angle.
The side is trapped inside the angle.
The side is trapped inside of the angle. So look at your diagram. Here's an angle. Here's another angle. Where's the side? Trapped between them. This is the reason that you're wanting to use. That's how those triangle congruence theorems work. A lot of you are still missing homework assignment 4 or 5. This is one answer for one of those questions. Not the only answer. There's another way you could have proved it. But this is one valid answer for one of the questions on homework 4 or 5. So if you get that back today, and I have some papers to hand back, you can definitely use this to help you generate the answer, okay? All right, we're almost done. I think I only have 2 more. They should go by pretty quickly. We're doing really good on time, by the way. It's only 10:25. Whoa. My camera had nothing to focus on. It was lost. Okay. Number 8 said, find the height of the tree. And I drew this picture for you. There's my terrible tree. And here's its shadow. Look, I tried. And then I did this like zip line thing. I don't even know. And then I put what looks like a door in the tree. And you're being asked to find the height of the tree. You want to find that. You were given that this part of this triangle is 6.4 meters and this is 7.3 meters, and you were asked to locate this. What could you do?
Squared plus b squared equals c squared.
Yeah, a squared plus b squared equals c squared again. Which side is c? The 7.3 side, because it is directly across from the right angle. If you did not calculate this correctly or you put C in the wrong place, please fix it on your paper right now. Give me thumbs up when you're ready. Thank you, thank you, thank you. Thank you. Thank you. Thank you. Thank you. All right, let's look at the last one. I know you may still be generating numbers on that, but you have the idea, so you should, I'll give you time at the end of class to go back and clean those numbers up. The next one was to find the value of x such that these two shapes were similar. That word "such that" just means I want it to be similar, and so you have to tell me what number I need to put into x in order for that to happen. But in order for them to be similar, I have to know something about their angles or their sides. So let's go to our definition and look at similar polygons real quick. Okay, here's my definition for similar polygons. Says that they're the same shape but not the same size, and they're similar if the corresponding angles are congruent, have the same measure, or the corresponding sides are proportional. Meaning I can write fractions between the sides in some relationship to each other, and they're always going to be equal. And I can use that to help me write an equation that then I can solve for x. There's two ways you could, well, more than two ways. There's a lot of different ways you could have set this up, but really at the end of the day, what I'm looking for is for you to have something that's one fraction equal one fraction. And if you can cross multiply and get it to solve, I would love to see that. If you set it up properly, but you got it to a point where we didn't have the skills introduced for you to solve it, I still gave you credit if you got the other cross multiply one correct as well. So here's one way that you can put them together. These two as a fraction equal these two as a fraction. And then we'd cross multiply and solve. But look at the problem with our cross multiplication here. You're going to end up with something like this. Do you know how to handle this? Did you see this in Algebra 1 at all? No. So you probably don't have the tools to solve this, but if I saw at least this much setup, I went, okay, you know to cross multiply and you know to get it proportional. One fraction equal one fraction. And then I just looked at the other cross multiplication one to make sure that you could do it. If you want to generate this down to a number, you can go another way, like maybe the whole numbers together, the 6 to the 5. So 6 over 5 equals. Now, when you do it this way, the 6 came from the triangle on the left, so I have to put the triangle on the left's information on top. Both of these proportions are correct. One of them is just easier to solve. Okay? There's other ways you could set this up as well. Again, some will generate things like we saw right here, that right now you don't have the tools to solve. Others will give you stuff like this, which you do have the tools to solve. Any general questions over anything that we did today? All right.